Assalamu alaikum class. Welcome to your first lecture of Introduction to Mathematics. This is your week one, and in the first week we'll be talking about the basic arithmetic operations and a basic look at algebra. Right. So this is unit 1.1, where the topic is basic arithmetic, including BODMAS, LCM, and HCF. So the topics that we'll be covering in this unit will be, first of all, BODMAS, then we'll move on to LCM, and then we'll talk about what HCF is and how to calculate it. Now, these are very basic topics in mathematics, and I'm sure many of you have a general understanding or a basic understanding of what these concepts are. But on the off chance that you are unclear about this, we'll be going through these topics in this lecture, right? So first up, we have BODMAS. Like I said, you must have already heard about this as well. It's possible that you heard about DMAS rule or BODMAS rule. It's the same thing. What is it? We'll try to understand this. But before we talk about what BODMAS is, we need to talk about why do we need BODMAS, right? So let's take a look at this expression, and suppose we have to solve this expression. So as you can see, there's a lot of things going on over here. We have to add the numbers, right? We have to multiply some numbers as well. We have to divide the numbers, and to top it all off, we have to square a number as well, right? So the question that arises is, what should we do first? Should we add first? Okay, then if we are to add first, should I just add 4 with 8, or should I add 4 with the square of 8, right? And similarly, these different types of questions, they come up in your mind. So to follow a systemized approach, to follow a methodical approach, whenever you're solving expressions, we have to utilize the BODMAS rule. And BODMAS rule, it is very much widely used in the world of mathematics. Before we move on to understand the basics of mathematics and the few fundamental concepts, we need to get BODMAS in our minds, right? So what is BODMAS rule? BODMAS rule, it decides the order of operations for adding, subtracting, multiplying, and dividing, etc. Right? So BODMAS is basically an acronym, right? It stands for brackets, orders, division, multiplication, addition, and subtraction. It's just a useful acronym to help you in remembering what you're supposed to do first. So whenever you see an expression, the first thing that you have to solve is you have to solve the brackets. Do all the operations that are contained inside the brackets first. When you're done solving whatever expression is in the brackets, then you have to move on to the orders. Now, what the order here means, order means like the powers or the square roots, or like, for example, if I say 8 square, now this is a power, 8 power 2, right? Or 8 cube, now this is 8 power 3, right? So first of all, we have to solve whatever is in the brackets. Then we have to move on to the orders. We have to take the squares or the cubes or even the square roots or the cube roots, all these examples. Next up, there's division. You have to, when you're done with the brackets and the orders, then you have to perform division, and then subsequently you have to do multiplication, then addition and subtraction. So BODMAS, BODMAS, this is the rule, and it's a useful acronym that helps us in remembering what we are supposed to do first, right? So let's take an example. We'll learn how the BODMAS rules work. The rule works with a useful example. I'll be using the same expression that I used in the original slide, right? So this was what the expression was. So according to BODMAS rule, we have to start off with the brackets, right? And the brackets are right here, 30 divided by 5. So we have to solve whatever is in the brackets. 30 divided by 5 is 6, right? So we'll place 6 right in this place. And this will give us 4 plus 8 square multiplied by 6 right here, okay? After this, we're done with the B, the brackets. Then we have to move on with the O, the orders or the squares, right? So we have to see, is there a square anywhere over here? Yes, there is. 8 is being raised to power 2. So we have to square the number 8. 8 squared is 64. Replace this right over here. What we get is 4 plus 64 times 6. Next up is division, but nothing is getting divided anywhere over here. So we'll skip that and we'll move on to multiplication, the M part. So we have to multiply 64 with 6. We cannot add 4 and 64. We have to first of all multiply 64 with the number 6, which gives us 384. And lastly, we have to add. Okay, so 384 plus 4 is 388. So the answer to this expression is 388. You will notice that if you were not following the BODMAS rule, we can have different answers. You know, if we were, let's suppose we started adding first, or let's suppose we started multiplying first, we would have some various different answers, and those answers will be wrong answers. So it's very important to follow the BODMAS rule. Let's take up another example. In this case, right over here, right? So let's see. Brackets, there are no brackets, so we'll skip that. Orders, there are no orders here as well, we'll skip that as well. Division and multiplication, so we're supposed to divide it and we're also supposed to multiply it, right? So you need to do division and multiplication first, but you have one of each. So start from the left and we work across to the right, which means 6 divided by 2, we get 3 over here, right? And then you multiply 7 with the number 4. 7 times 4 is 28. And then you replace 3 right over here. You put this value of 3 right over here, and you put this value of 28 right over here. What do you get is 3 plus 28. Calculate your answer and you get the answer, which is 31. Okay. Similarly, I have another expression right over here. 4 times 3 plus 2. Now you may think of multiplying first, but you have to remember we have to solve the brackets first. So solve the expression in the brackets. 3 plus 2, we do it and we get 5. And then you multiply this number 5 by the number 4. And 4 times 5 is 20. Now, if you ignore the brackets and you did your calculations from left to right, you would get 14, like 4 times 3, 12 plus 2, 14. And remember, this is the wrong answer. So again, very important to follow the BODMAS rule. If you feel that there are still some issues, and if you feel that this is still not clear, you can always practice the expressions. So and I've also given the answers right over here. So if the answer of this expression is right here, and the answer of this expression is right here, so go ahead and try to solve these expressions on your own when we're done with this lecture, right? Next up is LCM, or least common multiple, right? So again, you must have a general idea what a least common multiple is, but we'll go through it anyway. So a multiple, basically, what is a multiple? A multiple of a number is the product of the number and any other whole number. For example, if you multiply a number with another number, you'll get a product, right? Or a multiple. For example, if I were to say 8 times 2, so 8 times 2 is basically 16. Now this 16 right here is a multiple of the number 8, and 16 is also a multiple of the number 2, right? So like, for example, this is the table of 2 right over here. 2, 2, 4, 6, 8, 10, 12. So all these values, these 2, 4, 6, and 8, these are all multiples of 2, right? Similarly, the table of 4, we get 4, 8, 12, 16, 20. These are all multiples of 4. And likewise for 5, right? So these are all multiples of 5. So I hope you get a general idea of what a multiple is. So what is a least common multiple? The thing that you need to realize is, we already understand what a multiple is. I just told you. Then least, so this will be something that is the smallest number, and common means that it will be between 2 or more numbers. Like if I say what is common between this and this, object A and object B, that means we're talking about 2 objects, right? So always remember, LCM will always be between 2 or more numbers. You cannot say that what is the LCM of 2. No, you have to say what is the LCM of, let's suppose, 2 and 8, something like this, right? So LCM is basically used in solving the fractions by helping in finding a common denominator. I'm sure you must have a general idea of how we're supposed to solve denominators. For example, if I have something like 7 divided by 2 plus 6 divided by 5. Now you have to realize, I'm sure you understand that we cannot just add these numbers. We can't say 7 plus 6 is equals to 13. and 5 plus 2 is 7. No, this is not how we solve fractions. We have to find a common denominator, right? We have to make the denominator same, and then we add the numerators. So LCM is used to solve these fractions, right? Least common multiple is found between two or more numbers. Assuming we have two numbers, it is the number that is a common multiple of all the numbers in question. Basically, so I'll go through this first. L is for least, it is the smallest possible. C is for common, both numbers must have it, and M means a multiple of both numbers. Hint: the LCM of two numbers will always be greater to or equal to or greater than the larger number. Let's take a few examples, and we'll see how we're supposed to solve for the LCM. For example, if I have the number 4 and 3, and I'm asked to find out the LCM of 4 and 3. So the first step you have to do is write down the multiples of 3 and then 4. So you write down the multiples of 3. What are the multiples of 3? 3, 6, 9, 12, 15, 18, 20, like right? And then you write the multiples of 4. 4, 8, 12, 16, 28, right? Now what you have to do is find out whatever is common between the numbers that are common between these two numbers, right? So 24 is common in 3 as well as in 4, right? Then we see 12 is also common between 3 and 4, right? And if we had written more multiples, I'm sure we would have found more numbers common as well. But you notice that 12 is the smallest number that is common. We cannot take 24 because 24 is bigger than 12, right? So we have to take the least common multiple. So 12 will be the least common multiple of 3 and 4. You will notice that 24 is also common, but it is not the smallest. Hence, 24 is not the LCM. The LCM is 12. Okay. So let's take more examples. Suppose we have to find the LCM of 10 and 30. So we write down the multiples of 10, write down the multiples of 30. What do we get? You'll see that 30 is common right here, right? And there are more multiples of 10 as well. 60 is also a multiple. 60 is also common, but again, we'll not take 60 because 30 is the smallest common multiple, the least common multiple. So the LCM is 30, right? Again, another example of 12 and 18. When you write down their multiples like this, you find out that 36 is the smallest number that is common to both of them, right? So 36 is the LCM of 12 and 18. So this is how you're supposed to find out the LCM. Next up is the HCF, the highest common factor, and this is pretty much similar to how we find out the LCM, but there's a few general differences. In LCM, we discussed multiples. We were talking about multiples in LCM, right? Lowest common multiple. HCF is highest common factor. Factor is a different thing than multiple, right? Now in this section, we'll be discussing factors. Factors is a number that divides another number evenly. For example, 10 is divided evenly by 1, 2, and 5. And so 1, 2, and 5 are the factors of 10. For example, if I say the number 10, I'm trying to divide it, right? So if I divide it by the number 1, I'll divide it 10 times. I'll get a whole number. If I try to divide the number 10 by the number 2, I'll get the number 5 over here, right? So all those numbers that divide 10 evenly, they are called the factors of 10. Let's suppose if I say 10 and I divide it by the number 3, the answer over here will be 3.333. It will be in fractions, right? It's not an even number. So it's not a whole number per se. So 3 is not a factor of 10. This is what factors are, right? So HCF, we'll be talking about the highest common factor. So like LCM, we'll be finding a number that is common to two numbers, but this time we're dealing with factors and we're looking for the common factor that is the highest. So two differences in LCM and HCF. We're dealing with factors here, not multiples, and we'll be taking the highest number, not the smallest number, okay? Now, how we're supposed to find it? Let's see by an example. The HCF of 10 and 15. We need to find out the HCF of 10 and 15. So how do you do that? You write down the factors of 10. Factors of 10 are 1, 2, and 5, right? There's nothing more. Like 6 does not divide 10, 7 does not divide 10, 1, 2, and 5 divide 10, right? Then you write down the factors of 15. So 1, 3, 5. Now you notice the numbers that are common to both of these. 1 is common and 5 is common. Now again, I'll reiterate that we are trying to find out the highest common number. So the highest common number will be the number 5, right? So the HCF of 10 and 15 is the number 5. Another example is 12, 24 and 36. We find out the factors of 24, 1, 2, 3, 4, 6, 8, and 12. And the factors of 36 are 1, 2, 3, 4, 6, and 12. We find out the highest common factor, which is 12. So the HCF is 12, right? So this is what we studied in unit 1.1. We studied about the BODMAS rule, we studied about the LCM, and we studied about the HCF. I hope you had fun learning about this. You will see some exercises regarding to this also, and I will see you in the next lecture.